All right, this video is going to go over how to convert, order, and compare fractions, decimals, and percents, something that you've been doing since 6th grade, maybe even a little sooner. Right? So there's some key vocabulary we're going to start with, and then I'm going to show you the 6 different ways to convert from one type to another. You'll notice that in this note taker, some of the directions are already written down, and then we'll talk through the examples together. Other times we'll have to write certain things down. All right, so to go ahead and start off, we've already gone over the real number system, but let's just recap what we need to know. A rational number is any number that can be written as a fraction. So some examples that we can take and put down just so we can see all the different varieties are things such as 2 2/3, which is a mixed number. So mixed numbers are fractions. 0.4, which is a decimal that can be turned into a fraction. -2/5, negative fractions qualify. -1.3, because that can be turned into a fraction. And 0.7 repeated. Remember, all your repeating decimals can be made into fractions as well. Right, so the next vocabulary word we want to look at is called a terminating decimal. And this is a decimal that ends. When something terminates, it stops. So it's a decimal that ends and has no remainder. So if you were to divide it, there would be nothing left over. Right, and some examples of what those look like are your basic decimals. So 0.625. Doesn't matter how long the decimal is, as long as it stops and doesn't keep going. 1.7, -4.39146. Yes, it's long, but it doesn't keep going. It stops, so it terminates. Right? The next word is a repeating decimal. If it's not a terminating decimal, it will be a repeating decimal. And this is a decimal where the digits keep repeating. So there is a repeating pattern to them, right? And that's what makes them rational, because we make them fractions out of it. So some examples might be 0.555 ... It tells you that the 5s keep going, right? Another example might be if we have -1.414141... ... Right? So you see the repeating pattern happening behind your decimal, right? Bar notation goes along with repeating decimals. This is the bar over the digits to show who is repeating. So when you see that bar over certain numbers, those are the only numbers that keep repeating in your problem, right? So I'm only going to give you one example here. If I have 0.307 and the bar's over the 3, 0, and the 7, that means that you're going to have 0.307, 307, ... And it'll keep going, right? If it's only over 2 numbers, then those are the only 2 numbers that keep repeating. If it's only over 1 number, then that's the only number that keeps repeating. All right, and then in this category, a percent is a ratio that compares a number to 100. The word percent actually gives away the key phrase there. Per cent, there it takes 100 cents to make $1, so it's per 100. Right, so out of 100. Right, now we're going to go into the rules for how to convert from back and forth between those 3, fraction, decimal, and percent. Some of them are going to be a little easier than others for you, and some of them you will need to calculate, while others you can just look and visually determine. All right, so the first thing we're going to start off with is how to go from a fraction to a decimal. And you'll notice that it says right beside it how to do that. You divide the numerator by the denominator, which means top divided by bottom. All right, so some examples that we want to have here. All right, some examples we want to go through here are just the different varieties that you might see. So if you have the fraction 3/5, that's 3 divided by 5, which is going to make 0.6. When you are dividing your fractions to make a decimal, do not round anything off. Write it exactly as it appears. Right? And then we also have to be able to turn mixed numbers into decimals. So if I have -2 and 5/9, Okay, the -2 is a whole number, and whole numbers always go in front of the decimal. So here's my decimal. -2 is the big number, which goes in front. Now for 5/9, you use the calculator and do 5 divided by 9, and you'll see that it comes out 0.555555. So to shorten this, we write 0.5 with the bar over it. Right? So whatever that big number is has to go in front of the decimal. Then when you divide, you'll get the number that goes behind it. All right, so that's not too difficult to do. Now we want to go from a decimal to a fraction, which tends to be a little harder for some of you. Right? And this is where you write the decimal over the place value of the number, tenths, hundreds, thousands, etc., and reduce it. You have to know how to reduce your fractions, because a reduced fraction is the only acceptable answer to these. If it's not reduced, you do not get credit for it. Right? So the first one that we want to look at is if I have -0.45, right? You always want to look at the last number, the place value of the last number. So that 5 is in the hundredths place. So this is -45 over 100. That's how you determine what the bottom number is going to be, right? And that can be reduced. If it ends in a 5 or a 0, always start by dividing by 5, right? And that'll help you get to the answer. So if I divide top by 5 and bottom by 5, whatever you divide each by, it has to be the same number. -45 divided by 5 is -9. And then 100 divided by 5 is 20. 9 and 20 cannot go any lower, so -9/20 is your final answer for this one. All right, for the next one, if I have 3.55, you are going to have to be able to turn these types of decimals into fractions. Remember, the number in front of a decimal makes a whole number. So it's going to be a mixed number. The 3 is big, right? But the decimal behind it, you have to determine the place value of the last number, which is that 5. So once again, that's the hundreds place. So this is 55 over 100. 55 over 100 can divide even lower. The 3 stays a 3. You don't ever mess with the big number. So we're going to divide by 5 again. Remember, if it's an even number, pick a 2. All right, if it ends in zeros, pick a 10. Use your division tricks to help you out with this. So keep the big 3. 55 divided by 5 is 11, and 100 divided by 5 is 20. 11 over 20 can't go any lower. This is your final fraction. So you will have to write some numbers as mixed numbers, and you'll have to write some as regular fractions. All right, now, along with the lines of taking and writing a fraction, there is a special case for repeating values. Those are those numbers that keep going on and on and on. You're going to place the decimal over 9s instead of 10, 100, 1000, and so forth, and then reduce. Right? My trick in saying this is that if there's a line, you need a 9. They rhyme. Right? So line 9. And that'll hopefully help you remember how to make the fractions out of this. Right, so we'll take and do 2 examples of these as well. So if I have 7.15 and the line is over the 0.15, right? The 7 is a big number, so it stays big, right? And then the 15 is the one that's got the line over it. So that's what's going to need the 9s under it. So we have 7. You'll have to excuse the board. The board is acting weird today. Okay, and then 15 is going to go over top of 99. However many digits you have underneath the bar, that's how many 9s you're going to need on the bottom. Right? Okay, let's see if the board works better for us now. So a big 7, and then 15 goes over 99, and then you want to reduce. Always check to see if you can divide by a 3 or a 6. Typically a 3 will work. So if I divide 15 and 99 by 3, I end up with 7 as the big number, and then 15 divided by 3 is 5. 99 divided by 3 is 33. 5 over 33 can't go any lower. This is my final fraction. All right, so if I look at another one that involves repeating numbers, if I have -0.123 with a bar over the 1, the 2, and the 3, right, I need a negative sign. Always keep your negative sign. And then that 1, 2, 3 that has the bar over it is going to be on the top. But because there's 3 digits on top, I need 3 9s on the bottom. Okay, and then once again, try to divide by 3. Okay, if you divide by 3, then you're going to get -4 over 333. And if you check your fraction back in the calculator, it should give you the decimal you started out with. So you can check your results and see if it worked or if it didn't work. Right? But going to fractions tends to be a little bit of a hard point for us, so we're going to keep practicing with that over the course of the new unit. All right, for the next section, you're going to take and go from decimal to percent. And if you can read through here, the way you do that is to move the decimal to the right 2 places, or if you want to use a calculator, you can multiply by 100. Most of us can move the decimal just fine, right? And if you want to help yourself remember how to go from decimal to percent, think of it in alphabetical order, right? And in alphabetical order, the D goes to the P. So that means you're moving your decimal to the right. And you just have to remember 2 places. All right, so there's no math attached to this. If I give you 0.009 and I tell you to make it a percent, you're going to take the decimal and go 1, 2 places to the right, and then that gives you 0.9%. You must put the percent sign behind your answer or it is not complete. All right, so for the second one, if I give you 2.14, again, take the decimal and go 1, 2 to the right, and that gives you 214%. If the decimal's in the back of a number and you have no more numbers after it, you do not need to put the decimal there. Okay. If I give you ones like 0.8 and I ask you to move it, make it a percent, you're going to go 1, 2, and when you have that empty spot, you have to fill it in with a 0. So this is 80%, not 8%. You have to go twice. Okay. And then repeating decimals are a little trickier, not too bad, but you have to remember that the number that has the line over it is really going to keep going right behind it. So you're going to have to move 1, 2 places, and that gives you 77.7, but that last 7 doesn't stop, right? It keeps going. So that's 77.7 with a bar over it percent. In repeating decimals, you have to have that repeating bar in your percent sign to show that it does keep going. All right, so that's from decimal to percent. Then when we go the other directions, which is just as easy, we're going to go from percent to decimal. So once again, you can use alphabetically. Here's my D, here's my P. If I want to go from percent to decimal, notice my arrow is going to the left, so now I'm going to move decimal to the left 2 places. Or if you want to use the calculator, now you can divide by 100. Most of us choose to just move our decimals. All right, so some examples of what you would see here. These are all percents to start with. So we have 2%. When you don't see a decimal, that means your decimal is right behind the number. So you can put it in there. And we want to move it twice to the left. Once, twice, and when we do that, we have to fill in our missing spot with a 0. So this is 0.02. Okay, and that's what makes our decimal. All right, so if we have another one, we have 0.41%. There's already a decimal in it, so we're going to move it twice to the left. 1, 2, put the extra 0 in there, so 0.0041. I don't mind if you don't put a 0 in front of the decimal, but just make sure that I can read the decimal and that it's there. All right, so if I have 209%, okay, the decimal's behind the 9 at this point, go to the left 2 places, and that's its new home, so 2.09. Right, it's just counting left and right for when you're converting. All right, now number 4 is going to be one of the trickier ones, right? And this is one that we have to stop and pause for. It gives us 6 1/5%, and it asks us to make a decimal out of this. Well, you haven't really made a decimal until you've moved the decimal. So before we can do this, though, we still need to keep it a percent, but we need to change it to something we can work with. 1/5 is 0.2, so this is the same as 6.2%. Notice I still have my percent sign. I haven't done anything except change the 1/5 to a decimal. Right, so now I still have 6.2%, and in order to make it a decimal, I physically have to move the decimal 2 places to the left. So my final answer is 0.062. Right, a lot of people think that just by turning the fraction into a decimal that they're done, but you haven't actually moved the decimal, so you're not done. All right, for the next 2 sections, we're going to kind of skip the middle guy and go from one extreme to the other. So we're going to go from fraction to percent. And you'll notice in the directions that it says turn it to a decimal first and then turn it to a percent. So the decimal is your middle ground. And the same thing's going to be true for the next part too. So if we're going from fraction to percent, all right, let's start with 8/5. We want to turn that to a decimal, so 8 divided by 5 is going to give us 1.6. And then to make a decimal into a percent, we're going to move it 2 places to the right, which gives us 160%. So our final answer is 160%, okay, but you had to go through the decimal to get there. So number 2, we're going to try the same approach. If I have 1/200 and I want to make a percent out of it, we have to go through the decimal. So 1 divided by 200 makes 0.005, very tiny. Okay, and then from there, we want to make it into a percent. So we're going to go 1, 2 places to the right, so that makes 0.5%. I'm okay with you giving that to me that way. All right, if you recognize that 0.5 is the same as 1/2, you can get even fancier and say that's 1/2%. Both of those mean the exact same thing. It's whichever one you're comfortable with giving as an answer. Right? They both are the right answer. All right, for the next part, we're going to go from percent to fraction, which, like I said, anytime you go to a fraction, it does make it a little harder, right? But the nice thing about percents is that they're always out of 100, right? The only time you can't use that trick, right, is when you have a decimal involved, so we have to be careful. Right, so if we turn the percent to a decimal and then the decimal to a fraction, we can get it there, or we can just place the percentage over 100 except for decimals. Right, so taking a look at what I'm talking about here. If we have 16% and we want to make it a fraction, well, 16 is a regular whole number, so let's take 16 and put it over 100. All percents are out of 100, right? And then we can reduce it. So 16 and 100 can both be divided by 4. Okay, if you don't know that, divide by 2 and then divide by 2 again. You have to reduce it until it can't go any lower. 16 divided by 4 is 4. 100 divided by 4 is 25. 4/25 is the fraction, and it can't go any lower. You can double check, do 4 divided by 25 in your calculator, and see if it gets you back to 16%. Right, for the second example, if I have 123%, okay, you can stick it over 100. Right? Or you can go the decimal road. If we're going to go the decimal road, our decimal is behind the 3, and we would have to go 2 places to the left. So that makes 1.23. And now we can make that into a fraction. The number in front of the decimal is my big number, and the 3 is in the hundreds place, so that would be 23 over 100. And this would be your final answer because it can't reduce. Right? So you can decide if you like the decimal road better or if you would rather stick it over 100 and go from there. Right, now the only one you cannot stick over 100 is this next one. If I give you any kind of decimal in a percentage, you can't stick it out of 100 because decimals don't go in fractions. So the first thing you have to do is actually make it a decimal by moving the decimal. So I'm going to move it 2 places to the left, which gives me 0.003. And now this 3 is in the thousands place. Remember, it's tenths, hundredths, thousands. So this 3 goes over 1,000. And I cannot reduce it, so this is my final fraction. Okay, so be very careful with some of those in terms of figuring them out. All right, for this last section of your note taker, it's going to be determining who's bigger and putting them in order, which we'll do a lot more of this in class, right? But I just wanted to give you a taste of what's coming, right? You're going to use the less than, greater than, or equal to signs, right, when it comes to who is bigger. So if I give you two fractions, 5/6 or 7/9, right, and we want to determine who is bigger, right? The best thing to do is down here in the hint. Turn everything into decimals and then put them in order or compare them. All right, so if we take 5 divided by 6, we get a certain decimal, and if we take 7 divided by 9, we get a certain decimal. So let's take a second and see what those come out being. Right, so 5 divided by 6 is going to give us the decimal 0.83 with a bar over the 3. You can think of it like money and round it to just 83 cents. And then for 7 over 9, if we make it look like money, we're going to round it to about 78 cents. So if I'm looking at 83 cents versus 78 cents, the bigger one is 83 cents, which means that 5/6 is the bigger fraction. Right? For the next one, if we're going to compare 4/7 to 70%, again, always go to the decimal. Right? So for 4 divided by 7, right, and make it look like money, we're roughly at about 57 cents. And then if we take 70%, remember you have to move your decimal 2 places to the left, that gives us 0.70. Right? So 70 cents is a lot bigger than 57 cents, so that means 70% is our bigger number. Right, then for the next one, you have to be super cautious in the world of negatives because the closer to 0 it is, the bigger it is. The farther away from 0 it is, the smaller it is. All right, so here are our two values. Right, in terms of making them look like money, this would be negative 2.40. In other words, somebody owes you $2.40. And then in the other one, it would be negative 2.67 if we rounded it off. So the person who is bigger is the person who owes you the least amount of money. So in this case, $2.40 owing us is a lot better than owing us $2.67. That means that this number is bigger. Right? So always try to make it into decimals and money because everybody understands money. Right? So for number 4, when we're putting them in order from least to greatest, right, then those are going to be the same deal. Put them in order in decimals first and then turn them into putting them in order. Right, so we're going to cross off the number 5 part. We're going to put them in order on that side. All right, we're going to do decimals first. Negative 2/3 turns into negative 0.67 roughly, right? Because if you take negative 2 divided by 3, you get 0.6666. Right, so it's about 67 cents. Then we have 0.7, which is about 70 cents. Make it look like money by putting 2 digits in there. The next one already looks like money, negative 0.68. And then the last one, 75%, is going to be 0.75. right, so now that we've got them all into decimals, we want to put them in order from least to greatest, little to big, and we're going to use the decimals to help us out. All right, negatives always have to go before positives. So now we're going to look at the negative 67 cents and the negative 68 cents. Remember, the person who owes us the most is the smallest. All right, so negative 68 cents owes us more than negative 67 cents. Negative 68 is your biggest number. Okay, you always write the original number from the problem, even though you changed it. Now, negative 67 cents is the next one, and that goes with negative 2/3. Okay, don't write the decimal, but write the original number that gave it to you. Now, using the positive, 70 cents and 75 cents, we know who's little and who's big with that one. 70 cents is the next one, so that's 0.7. And then the largest number in this list would be 75%. So when you're putting things in order, always go to the decimal format first, and then use that to help you put them in order and determining if it's least to greatest or greatest to least. All right, so you're going to use these notes to help you take your Edmodo quiz and to help you out in class with other assignments that we decide to do.